Hello folks, I wanted to show you some updates on the latest project, um, the TSN 3-axis magnetometer. Um, Due to some health reasons and the fact that I haven't got Bluetooth communication fully implemented yet, I don't have the prototypes out, but the software and the hardware are to a state that I think I can safely prototype and send some units out without worrying about firmware on the 18 mega microprocessor having to be rewritten, or any changes to the circuitry. Semi-sophisticated firmware on an Arduino Nano. This is the firmware that's loaded onto the Arduino. We'll close that and give you an idea of the board design and the schematic. Here's your Arduino. This is a TTL converter, voltage divider, 5 volt to 3.3. The Bluetooth radio on the receive end uses 3.3 logic levels. Reset line, the necessary lines for the I2C bus for the magnetometer and its power and ground, and the external power supply for when you're not running on USB. And I've added a buzzer as something new. I notice sometimes I get spikes. It picks up transients, but when it's in 1 second plot mode, meaning it takes a sample each second and plots it, sometimes those don't get caught. And I'll show you the different plotting modes. So I decided to have it alert you with a short tone, pretty loud beep at 2.6 kilohertz if there's a spike in B total. I think this will, I'm not quite done routing all the circuitry the way I want it exactly, and I have a few more labels to put, but that's basically going to be the board design. It'll fit into a little project box. And before I show you the actual plotter, there's a utility that will come with it that'll allow you to well, first of all, it'll find the magnetometer's COM port and allow you to input your magnetic declination and some other things and write that as a config file. I'll run that real quick. It's not quite done, but you can get an idea of what it looks like. I do have it paired right now, and the magnetometer is on. So this is sort of what you'll see. Just giving you some instructions, telling you what it's going to do. These are the steps you'll go through: setting up your COM port. If you're using Bluetooth, it'll do a Bluetooth discovery and communications test. Calibrate is where you'll enter your magnetic declination, and then save your config or exit and save. So, like in this instance, it's ready to search. So I click on the COM port button, and it takes a few minutes. So if you watch down here, it's going to go through all available COM ports nothing found on COM 1, so it's going to move on to the next available COM port and look for the handshaking signal. Now, since there is a virtual port set up for Bluetooth, it'll find two ports. It'll find the USB port and the virtual inbound port on COM 6, which happens to be the incoming port that the Bluetooth device created. So as you can see, it found the handshaking signal on COM 4. Connecting to COM 6, and it also found it because Bluetooth is on, but it's usually going to be the first port. And it tells you right here, magnetometer found on COM 4, and then you would click next. And this is the part that's not quite done yet. These links will take you to helpful websites to help you determine, calculate, and convert your magnetic declination from latitude and longitude coordinates to radians, and then from radians to degrees. And then as you can see, the rest of that's not ready to go yet, but then you would enter it into a text box, and then we would proceed to the Bluetooth test. But enough of that, and I can close this utility. Now to the utility itself. Quite a bit of code, but it does quite a few things. We'll go ahead and hit run. This is not exported as a standalone app yet, so it may run a bit slower than the final version will. So hit run. It's going to do some setting up and configuring. It's loading images, setting up variables, and doing some COM port checks. Should start right about now. There we go. So I guess I'll start with the units of measurement. Coming from the Arduino, from the magnetometer itself, everything is in milligauss, and there are two zoom modes. The default zoom mode is positive 1200 milligauss to negative 1200 milligauss, and also indicating direction, northward or southward. As far as the legend, the orange is B total, which is calculated from BX, BY, BZ. Yellow is your heading, and it'll be 0 to 360, using 0 as a reference. So you can see here's 240, and we're at a heading of about 282 degrees. So that's about right. It's right on. Green is your BY. It's you can see your stats down here, the raw numerical data, and you can see that all these match. This compass shows true north. Everything is time stamped in UTC. It gets this directly from the user's computer. If you have chosen to include your magnetic declination, it shows your declination here. This icon over here shows you how you're connected and the status of it. I'm on USB, and of course I'm connected. This meter right here is a B total meter. total field strength, it goes up to 2400 milligauss, or 240 microteslas. During the course of the plot, it takes 900 some samples. Each time it takes a sample, it recalculates the average. So that's what the average each axis is. And then it'll save this to a log file every time the plot resets, which is 15 minutes, depending on the plot mode you have it in. The buttons at the bottom, none of these are stock. I've created all the buttons myself. This is to reset the plot. So clicking that just simply resets it, resets all variables, clears all the buffers, and you start from scratch. This is to change the plot mode. There are two modes. It can take a sample every second, or you can put it into a real-time mode, which I can demonstrate now. And I'll show you why that's useful. We're mainly using this utility to look at geospace events, any kind of space weather, geomagnetic storms that might affect the user locally. And we have picked up some activity during solar storms and times where there's a high KP index. I've got a strong neodymium magnet here. I'm going to get it close to the sensor, and two things will happen. You'll see the lines change. The BT meter will go up, and if it goes above 1500 milligauss or 150 microteslas, it'll give you an audible alert. So I'm about 12 inches from the magnetometer itself, and you can already see the effect that the magnet is having on the compass and B, X, Y, and Z. And as I get closer, it should start beeping, and you should start seeing the BT meter go up. Getting closer, it should start beeping now. Now as I pull away, everything should settle back down. I've got the magnet away from the unit right now. But if you put it in real-time mode, you can really see what's going on. So I'm going to go to real-time mode. I'm going to do the same thing. I'm getting the magnet closer to. Now you can start seeing, I'm sitting here drawing a sine wave just by moving the magnet in and out, and you can do it for each axis. I can come in from the side and just affect one. I can come straight down from the top and affect the Z-axis. It'll reset here in a second. Let's see if I can get just a Z-axis. I'm going to come straight down. Yeah, it's off the chart. Let me try the other pole. As I come down, this should go up. Yeah, you can see that BX and BY aren't moving much because I'm coming directly down on top. And so you can see B rising. And if you came from the side, let's see if I can affect either just Y or Z. Okay, this is going to affect the X-axis the most. And let's see, coming in from the Y-axis side, there you can see how Y takes a dive. So that's where the real-time plotting really is handy. Or if you see a lot of action during a geomagnetic event, then the real-time plotting mode might be for you. Going back to the 1 second plot. Now this is in zoomed out mode. if you're wanting to get a better resolution on smaller units, you can hit zoom in, and the only thing that's going to change is the scale. So when I zoom in, you'll just see the scale of the graph change. Zoom mode on, it's resetting, and now it's going to appear to be a lot more sensitive because you're looking at half the range that you were looking at before. So like zoom mode's on, and you can do these in any combination. Zoom mode is on. I'll turn on the real-time plot, and the transients and changes in the plot should be a lot more pronounced, simply because, well, we're zoomed in. So let's go back to the real-time plot, and we'll play with our neodymium magnet again. And I'm about 2 feet away, so let's see what it takes to get this thing to respond. I'm still about 18 inches away. So you can see how much more sensitive that is. As a matter of fact, I'll keep the magnet right where it is now. I'm moving it back and forth about an inch. Back an inch, forward an inch, back an inch. Now do that with the zoom out, and you'll see what I'm talking about. See how it's not so pronounced? You don't see that big of a change, but your scale is negative 1200 to positive 1200. Going back to zoom in, so you can see where that's useful. I guess this mode would also be useful to see how much electromagnetic noise might be in your environment. So that covers that. X saves the data, your configuration, the way you have it set up now, and exits the application screen. The disk will take a screenshot in case you want to catch something. Let me put it back on 1 second mode. I'll zoom out. Now, for instance, if I was to exit the application right now, it would know that next time you launch it, to do it in 1 second plot mode and to zoom out. If you were zoomed in and had it in real-time mode, it would save that, and that would be the default next time you load it. But the disk would just it'll just take a screenshot and restart. So now you got a JPEG file in the export folder. I'll attempt the Bluetooth. The code's not done yet, so it may lock up, it may do nothing. The only way I can tell it's doing anything is in the IDK console down here. So first I'll make the console bigger. Go back to the app. And it's attempting to connect with Bluetooth. If it's successful, I'll get a connection status 1. So it is connected now, but the code is not in place to take the data and plot it from Bluetooth yet. But I can go ahead and get the prototypes out, and this can be fixed in software later. But just wanted to give you a tour of the latest 1.7 beta, and hopefully we'll start rolling these out soon. Thanks for watching.